For this problem, we want to find the result of this trigonometric series. The first term, as you see, is 1 over sine of 1 degree, sine of 2 degree. The second term is sine of 2, sine of 3. And this goes on until we reach the term sine of 89, sine of 90. To solve this problem, we take one arbitrary term of this series and try to simplify that term. So if that arbitrary term is tk, is equal to 1 over sine of k degree sine of k plus 1 degree. To simplify this relationship, we multiply both sides of this by sine of 1 degree. So from here, we find 1 over sine of 1 degree times sine of 1 degree over sine of k degree sine of k plus 1 degree. Now we write 1 degree as k plus 1 degree minus k degree. So we replace for the numerator this sine of 1 degree here, sine of k plus 1 degree minus k degree. So tk would be equal to 1 over sine of 1 degree times sine of k plus 1 degree minus k degree over sine of k degree sine of k plus 1 degree. We now expand this term here into two terms. In other words, sine of a minus
So
b
here
is equal to
we
sine
have
of
one root of this equation.
cosine of
If
b
4x minus 7 is
minus
0,
cosine of a sine
and
of b.
x is equal to 7 over 4.
So this relationship,
And we see
would
that
be
in fact this
converted
is the
to
only real solution to the problem, because the second parenthesis here
sine of
x to the 100,
k plus
x to the 98, and
1
so
degree
on, x squared
times cosine
plus
of
1
k
is always
positive, and it cannot be minus 0. Cosine
So
of
does not
k
have
plus 1 degree
a real root
times sine of k.
So the only root for this problem, real root for this problem,
divided by
is 7, x equal to 7 over
k
4.
sine k plus 1 degree. Now we break this into two relationships, simplifying by sine of k plus 1 one time, and one time by sine of k degree. So this would be equal to 1 over sine of 1 degree times, from the first term we have cosine of k divided by sine of k. And from the second term, we get cosine of k plus 1 divided by sine of k plus 1. So this would be a typical term of this series after rewriting it in this format. Now, if we want to write the series again, we have this 1 over sine of 1 degree if we call this series as S times, this would be cotangent of k. So we have cotangent of 1 degree minus cotangent of 2 degree. Minus the next term would be cotangent of 2 degree minus cotangent of 3 The next term would be cotangent of 3 minus cotangent of 4, and this would be written likewise until we reach the term cotangent of 90, 89, and 90. So inside here, we can simplify 2 degree, for example. We can simplify 3 degree, and likewise we can simplify until we reach 89. So this series would be equal to 1 over sine of 1 degree, and the only term that remain would be two terms, the first term and the last term of the series. So the first term is cotangent of 1 degree minus cotangent of 90 degree. But cotangent of 90 degree is 0. So S would be equal to cotangent of 1 degree over sine of 1 degree. And we simplify this further by writing cotangent of 1 degree as cosine of 1 over sine of 1 degree, and the summation would be equal to cosine of 1 degree over sine square of 1 degree. So this summation term simplifies to cosine of 1 degree over sine square of 1 degree.